Alright guys, we're back in 11.2. We're in part 2 of it. We are looking at our last objective here. We are going to interpret some real-world graphs. Sorry in advance for all of the animal sounds you may or may not be hearing. My puppy is being a little bit rambunctious with the cat right now, so bear with me. Okay, so we're going to read some graphs. And when we do this, we're just going to follow our close reading strategies. We're going to make sure we're reading to make sense, reading for details. These details include these key features. We have key features like amplitude, period, phase shift, midline. We're going to read to represent, and we're going to read to check. So here's example number 3. Again, here's all the different reads we can do for our close reading strategies. Here's the example over here. It says the sine parent function y equals sine of x has been transformed. Determine the equation of the sine function in the graph below. Alright, so not so much of a real world situation yet. We're just reading this graph in order to write the equation. Alright, so looking at my graph for details, I'm going to look at these key features. My maximum value. So my maximum value is here or here, right? Either way, that maximum value, we follow it across to the y-coordinate of 1. So I have a max value of 1. A minimum value, here's my lowest value on the graph. Again, here's another minimum value. And that's going to bring us to -5. And identifying your maximum and minimum is helpful because we can determine our midline here. I guess I could go write -5 over by minimum. And so my midline is going to be in the middle of the maximum and minimum value. So I can count. It's 1, 2, 3, 4, 5, 6. They're 6 away from each other. So the middle of 6, right, would be 3. Half of 6 is 3. And so I can just go 3 units. 1, 2, 3. So here's going to be my midline. And sure enough, that does appear to be in the middle of my graph. So I'm going to go ahead and plot that also. And I now know what my equation of my midline is. I can go ahead and state my midline is y equals -2. It's that horizontal line. And so that also tells me that k is equal to -2. From the midline, I can also determine what my amplitude is. I could determine my amplitude using my maximum and minimum values and using the equation that amplitude is equal to 1/2 times the quantity of maximum minus minimum. Or I can just look at my graph and say, okay, well here's the middle of the graph. How far is the maximum value? Well, it's 3 units away. All right, well how far is the minimum value? That's 3 units away. So the amplitude is that variation. So I know my amplitude is my A, and my A is 3. Now if I were to look back at my graph and I recall that for sine functions, the 5 points for sine functions is 0, max, 0, min, 0. Right, that's the pattern. So 0 to my max, back to 0 to my min, back to 0. So this represents one cycle. Because this cycle begins at 0 here, the x value of 0, I know that there was no phase shift. No phase shift. And so that lets me know my h value is 0, or there is no h value. And the period, well, the period begins here at 0, and it goes all the way to 2 pi. And that's what my parent function does also. It goes from 0 to 2 pi. So then I know that I didn't have any kind of transformation for my horizontal stretch or my horizontal compression. So it lets me know that my b value is 1. So I can write that over here. B is 1. And so I think I'm ready to write my equation because I have accounted for my A, my B, my H is 0 since there is no phase shift, and my K. I also know this is a sine function. So my equation, my answer here, is going to be y equals 3 times sine of x minus 2. And this is the equation of the graph shown in this example. Alright, you have a U-try problem, so I want you to go ahead and pause this video and try this problem out. Okay, so going over this problem, the cosine function, we see it has a maximum value at 3. We see it has a minimum value. And when it talks about maximum and minimum values, it's talking about the y value, right? So we come over to find the y-axis. So -1 is the minimum value. And this really helps us to find our midline and our amplitude. All right? So it tells us that the distance between these, 1, 2, 3, 4, our distance is 4 between the max and the minimum. And if I want to find the midline, it's going to be right in the middle. So instead of going 4, I'm going to just do half of 4, which is 2. So 1, 2. So here is my midline, the middle of this graph. All right, so now I know my midline. Whoops. Is the equation y equals 1. And again, that tells us then that k is equal to 1. Again, I can use this to help me determine my amplitude. My amplitude is the variation of y values, or it's going to be that distance away from the midline. So the distance from the max value to the midline is 1, 2, and the distance from the minimum value to the midline is also 2. They're going to be that same value. So now I know my amplitude, or my A, is 2. Now we do have to be careful here because sometimes our A could be negative. So we do want to go and look at our function now. It's y equals cosine of x, and we're going to recall that for cosine, it goes max, these 5 points, right? It goes max, 0, min, 0, max. And so we do start up here high at our max. We go to the 0, and then down to the min, back to the 0, and to the max. And so I know it doesn't look like we're at 0 here, but when it says 0, maybe that really should say midline to help any kind of confusion. Okay, so we're back at this middle of the graph. Okay? And so this is going to be one cycle. What I've highlighted in black here, that's one cycle of our cosine function shown. And so that one cycle helps us to determine our period. So our period, looking at the x values, 0 to 2 pi. Oh, so that lets us know that our b is 1, again, because that's normally what our period is for the parent function for cosine and for sine, is 2 pi. So if that hasn't changed, then that lets us know b is equal to 1. Phase shift, our phase shift is our horizontal shift, left and right, but we began right here at the y-axis, and that's where we do begin for our parent function. So we didn't shift left or right, we stayed right here. So we don't have a phase shift. So we're ready to write our equation. It's going to be y equals 2 times cosine of x, no phase shift, plus 1. Alright, round of applause if you got it right. If you didn't get it right, go back, see what's up, shoot me an email. Let's try to figure that out. Moving on. Example 4. The cosine parent function y equals cosine of x has been transformed. Determine the equation of the cosine function in the graph below. Alright, so we're doing the same thing that we just were. We want to annotate the graph. Let's label some key features. So I'm going to actually do that on my graph here. So here's my max value. Come on, you. So max value is -4. I've got my minimum value here at -4. Did I say -4 before? +4 and -4. All right, so here's my max. Again, I was going to say -4. Max of 4 and minimum of -4. Again, that helps me to determine my midline. So my midline is right here in the middle of 4 and -4. So it's at 0. So my midline is y equals 0. Again, that tells me then that k is equal to 0. So there was no vertical shift up or down. Again, this helps me determine my amplitude. The amplitude is how far the max is from the midline, or the minimum is from the midline. And so I see my amplitude is 4. So A equals 4. What else here? Period. Our period. Well, we got to identify a cycle. This is cosine. So again, cosine goes max. And then we said 0, right? Or midline. Min 0, or midline, max. There we go. Okay, so if I'm following that pattern, what I see on my graph, we gotta start high. You gotta start at this max. Then we go to the midline, and then we go to the minimum value, and then we go to the midline, and then we go back to max. So that's going to be one cycle. And so when we talk about the period, we need to look at the x values. It goes from pi over 2, 1/2 pi, to 9 pi over 2. And so we need to count that. We're going by 1/2 pi. So this is like 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves pi, right? 8 halves pi. So I write that out, 8 halves pi. And so 8 over 2, we can reduce that. That's just 4. So 4 pi is my period. And that's going to help me out because I can now determine what my b value is, right? Because my period's supposed to just be 2 pi, but this time it turned out to be 4 pi, so that affects our function. So we know period is equal to 2 pi over b, right? So 4 pi is equal to 2 pi over b. And so if I solve for b and I do this whole cross multiplying, put this over 1, cross multiply, so I get 4 pi b equals, cross multiply, 2 pi, and then I solve for b, make some room here. Solving for b, I need to divide by 4 pi, so the 4's cancel, the pi's cancel. On the right side, the pi's cancel. So b equals 2 over 4. Right? And that can reduce. So b is equal to 1/2. And that makes sense because even though our graph got bigger, right? And so we think we should have a bigger number, the b's were the opposite, right, of what the a's are. So it's if b is less than 1, that's actually a stretch. If b is greater than 1, that's actually a compression. So now we know our b value is 1/2. All right, we've got our a, we got our b, we've got our k, we're just missing our h, and our h refers to our phase shift, if you recall. So the phase shift is our horizontal shift. And we do see that, hey, it's not starting on the y-axis like it should. The cosine function is supposed to start on the y-axis at the maximum value and then go down. And so we have this phase shift, and it's shifted over. So we can go and see how far from 0 did it shift. it shifted pi over 2 units. And that shifted to the right. So that lets us know h is positive, and it's equal to pi over 2. Alright, so we're ready to write our equation. Our equation is in the form y equals a times cosine of b times the quantity x minus h plus k. Alright, so y equals 4 times cosine of 1/2 times x minus pi over 2 plus k plus 0, and there is no k, so we can just leave it like that. So here's our answer. Alright, here's your you try problem. Go ahead and pause the video, give yourself some time to try it out, and then continue on to check your answer. Alright, let's see how you did. Our answer here is y equals 3 times sine of 2x minus 4. Alright, so let's see how we got all of that. This 3 is our amplitude, and so the 3 is saying that we're 3 units away from the max and 3 units away from the minimum at the midline. And our midline, hopefully you identified it. Here's our midline, the middle of this graph here. And remember, the midline is also our k, so that's why you see our k here is this minus 4. And then our maximum value, here's a maximum value up here at -1. Here's a minimum value down here at -7. And so again, we can see how far is that away? That's 3 units away. So that's why it's 3. It's a positive 3 because we're talking about the sine function, and our sine function is going to begin at the midline, and then it goes to the max, then it goes back to the midline, then it goes to the minimum, and then back to the midline. So here is our one cycle of our sine function, and we see that it wasn't reflected over the x-axis. So we know our a is positive. There's no kind of reflection. And then this 2 has to do with our b, and our b refers to our period. So we can see the cycle here has a period of pi units, right? That horizontal length where it begins at 0 and where it ends at pi. So our period is equal to pi. And then we can use our nifty formula. The period, write it over here, period is equal to 2 pi over, whoops, I got cut out somehow. Okay, 2 pi over b. And so we know our period is equal, we just said, to pi. So pi equals 2 pi over b. And we can just throw the pi over 1, so we have a fraction equals a fraction, we'll cross multiply. So pi b equals, cross multiply, 2 pi. And solving for b, we will divide by pi. So we're dividing by pi, cancel, cancel. So b equals 2. And that's how we put b 2 right here. We know there was no kind of phase shift. Again, the phase shift, our sine function, starts on the y-axis, and it still starts on the y-axis here. So there was no horizontal shift left or right, so that's why we don't have an h. Alright, we made it. We have a real world problem. This problem says the average water level varies from low tide to high tide as shown. What is a cosine function that models the water level in feet? What is a cosine function that models the water level as a function of time, h, hours? So we're going to do just as we have been doing. We're going to be labeling our key features. We see a maximum value here at 9.9 feet. So here's our max. And we see a minimum at 0.3 feet. Minimum. it also looks like it's drawing for us a midline, but we could always double check that math and make sure they're not just trying to trick us by using our formula to find amplitude, right? It might not be so easy this time to just count. So I could use my formula. I can say A is equal to 1/2 the max value 9.9 minus the minimum value 0.3. So A is equal to 1/2, or 1/2. 9.9 minus 0.3 is 9.6. And so then we take half of that. A is equal to, what is that? 4.8. So our amplitude is 4.8. So, well, let's do that math then. Let's see, 9.9. If we subtract 4.8, we get 9 minus 8 is 1. Bring down your decimal. 9 minus 4 is 5. Yeah, we get 5.1. Perfect. Okay, so this is our midline. So this is y equals k here. And so, we just found a few things out. All right, so our amplitude, we found out, is 4.8. Awesome. We found out also our midline, y equals k. So k equals 5.1. We are doing wonderful. We are looking at what function does it tell us here? Our cosine function. Okay, so the cosine function, remember that starts at the max. So cosine goes max, 0, or midline, minimum, back to 0, or the midline, and then max. And so I'm going to trace that here. Let's get a bit of a darker color. So I'm tracing one cycle of our cosine function. So there's one cycle there. And so we see the phase shift didn't really affect us. We didn't have any kind of horizontal shift. Remember, our cosine graph is supposed to start at the y-axis, and it does start at the y-axis. So phase shift is not part of this, or I guess we could write our h value is 0, right? There is no horizontal shift here. After tracing this, I can go back and I can look at my period. My period, this time it's in terms of hours. So at 0 hours all the way to, looks like noon. So from 0 to noon, that's going to be 12 hours. So our period, get me a different color here. Our period is going to be 12, and so then we can use our formula, period equals 2 pi over b, and we can solve for b. So if I know my period is 12, then 12 equals 2 pi over b. Again, put that 12 over 1, let's cross multiply. We get 2 pi is equal to, cross multiply, 12b. And solving for b, I'm going to divide by 12. So b equals 2 pi over 12, or b equals pi over 6 if we reduce our fraction. This is awesome. We've got our a. We've got our b now. We've got our h. We've got our k. We're ready to write our function. It does say that it would like us to write this in terms of h hours, as a function of time, h hours. So my equation will be y is equal to a, which is 4.8, times cosine of b, which is pi over 6, times the quantity x minus h, but h is 0, so just x, but x is h for hours, so h, plus k, so plus 5.1. All right. So there is my cosine function that models the water level as a function of time, h hours. You got a U-try. All right, U-try number 3, last U-try. Go ahead and pause the video, but before you do, I see already this kind of a little hard to read here. You know, like where is that minimum value? And so I just want to let you know that minimum value right there is actually right in the middle here. So it's going to be at -5. Alright, so hopefully that helps you out. Pause this video, work it through, and then check your answer. Alright, I hope you're ready for it. Here it comes. Y is equal to 32.5. Did you get that? Times cosine of pi over 6 t plus 27.5. Now these parentheses, if you want to, you could have the pi over 6 outside of the parentheses. Let me just rewrite it. And just the t on the inside, like that, if you prefer. Alright guys, I hope you got this. If you did, great. You can stop here. Go on to practice 11.2. If you didn't, hang tight. I'm going to talk a little bit about this. Thanks guys for checking in. So this problem says the average temperature of a certain area varies from -5 to 60 degrees Fahrenheit. The highest temperature is in July and the lowest is in January. What is a cosine function that models the temperature above and below the average as a function of time in months since July? All right, so we know it's going to be a cosine function. We also know, according to both the graph and the problem, we know our max and our minimum values. It tells us right here, and it shows us in our graph, right? When we talked about this one before. From there, we can easily find our midline. We could count that, or we could use our amplitude formula to find our A value, and from there we can find our midline. So maybe doing that, A equals 1/2. It's a half. 60 max value minus min value, so minus a -5. So A equals 1/2 times, this is 65. So our A value is half of 65, so that's 32.5. Alright, so that's how we get our A value over here. Our midline, this 27.5, we're going to get that by subtracting our A value or by adding our A value to find what's in the middle here. You know, maybe you were able to find the middle yourself, maybe you struggled with that. We could always find that middle by taking this amplitude away from that maximum value by subtracting it. So if we do that, 60 minus 32.5, oh, we better put a 0.0 up here. So we're going to borrow, right? This is going to turn into a 5, so that's going to turn to 10, but then we're going to borrow, so that's going to turn into a 9, and that's going to turn into a 10. So 10 minus 5, we get 5. 9 minus 2, we get 7, and 5 minus 3, we get 2. So at 27.5, that's how we get our K value, our midline. We see that there is no phase shift because our cosine graph, right, is supposed to start at the y-axis, and it does start at the y-axis. So we did not shift horizontally, left or right, so phase shift is none. And so the last thing we need to talk about is our period. Our period is our cycle length. So our period, if we jot down here, is 12, and jot down here is 0. And so this actually was just like the problem I did. So we can say our period is 12. So 12 is equal to 2 pi over b, and we can solve for b. Remember, we throw that 12 over 1, cross multiply, and that's how we find that b is equal to pi over 6. Alright guys and gals, again, if you have any questions that have not been answered, please shoot me an email, and we'll hopefully take care of it from there. Try out the practices, and I will chat with you in our next video. Thanks again.